Module 7, Lesson 3 covers solving equations with variables on both sides. And for me, this is where the math starts getting kind of cool and fun. We're going to take our little algebraic puzzles to the next level. And as we do this, we're going to, of course, have a content objective that says students will write and solve equations with variables on each side. The suggested pacing claims this will be a 2-day goal, and we have 18 resources to cover, so let's get started on them. Our inquiry question wants to know, how can you solve an equation with variables on each side of the equal sign? And they have us using a web sketch pad to try and figure this out. How to use this pad? Well, let's see here. First thing we're going to do is we're going to experiment by dragging objects from the storage area to the left and right side of the balanced pan. And then we're going to show the math sentence. And if you want to see the mathematical representation on the balance, yep, and then we're going to press restart and start it again. So, well, that sounds terribly exciting, so let's do it. So I've resized my screen here, and we've got some x's we can throw down over here, and a 5x there. And let's do a couple of x's here, and then a 1, and maybe a 5. And we're still not balanced, so let's take and throw down a couple more 1s right here. And right there, we finally got a balanced equation. And you can see, what do we have on the right? We have got a total of 2 x's. We have 3 1s and a 5, so on the right-hand side, the equation would be 2x plus 8. And on the left-hand side, what do I have? I have a 5x and a 1x, also known as 6x. So what would my mathematical sentence be? 6x plus 0 1s, because I didn't put any over here, is equal to 2x plus 4. So this is an example of having equations with an equation with variables on both sides. Now, I'm not going to spend a lot of time on these because it's not really a good use of our academic time. Instead, let's take a look at this learn example here. Some equations like x times 3x, like 8 times 3x is equal to 5x plus 2 have variables on both sides of the equal sign. To solve these, use the properties of an equality to write an equivalent equation with the variables on one side of the equal sign and your non-variable numbers, they need to go to the other side. Now, I'm going to go ahead and say, when I work these problems, I like to keep my variable numbers positive. Now, it's going to be up to you how you choose to do it, but when I do it, I like to work it so that my variables stay positive. Don't have to, but it helps for me. So moving through the steps, you've got 2 variable numbers, 3x and 5x, and you've got 2 non-variable numbers, 8 and 2. You've got to get all the variables on one side and all the non-variables on the other. If I wanted to keep my variable numbers positive, I'd have to take that 3x and move it to the right-hand side. But what did they do? They did the same exact thing. Maybe your textbook likes to keep them positive too. So they subtracted 3x from both sides. 3x minus 3x, those are going to zero each other out. And then 5x minus 3x, what's 5 minus 3? Well, it's going to be 2. So they have 2x right here. That 8. It came down, and then this plus 2, it came down as well. Now we need to go after that 2. It is right here. It is a plus 2, and we're going to make it go away by subtracting 2 on both sides. You subtracted 2 on the right, and these are going to zero each other out. And on the left, 8 minus 2, what's that going to be? It's going to be 6, which is going to give me now 6 is equal to 2 times x. From here, it should be pretty dang obvious how you're going to finish the problem. 2 is multiply itself times x, so we're going to divide both sides by, well, they screwed up. This right here should be a 2, not an x. They screwed up big on that one. And then from there, the 2 divided by 2 is 1. 1 times x is x. 6 divided by 2 is going to be 3. And check your answer. Your answer checks. All said and done, with the exception of their little x boo-boo, that's a pretty good way of solving these problems. But what if we had some wild and crazy desire to be able to solve these using algebra tiles? Well, lucky for us, the textbook has instructions on that
You
too.
can use algebra tiles to solve equations. First, model the equation. Use 8 1 tiles and 3 x tiles to model 8 plus 3x on the left side of the mat. Use 5 x tiles and 2 1 tiles to model 5x plus 2 on the right side of the mat. There needs to be x tiles on only one side of the equation, so remove 3 x tiles from each side of the mat. Now there are 0 x tiles and 8 1 tiles on the left side of the mat. There are 2 x tiles and 2 1 tiles on the right side of the mat. Next, remove 2 1 tiles from each side of the mat so that the x tiles are by themselves on one side of the equal sign. That leaves 6 1 tiles on the left side of the mat and 2 x tiles on the right side of the mat. Since there are 2 x tiles remaining, separate the tiles into 2 equal groups. There are 3 1 tiles in each group, so x equals 3.
And that's pretty much exactly how we worked the same problem when we were using the equation method. Personally, I like the equation method better, but sometimes it's fun to play with toys too. And that leads us to working example 1, which says 6n minus 1 is equal to 4n minus 5. Now once again, if I'm working it, I'm going to do it to where I can keep the variable numbers positive, which means in this case I would need to start off by subtracting 4n from both sides to get my n's on the left hand side. Let's see what the textbook did. They started off by doing exactly what I would do. They subtracted 4n on both sides. These 4n's on the right, they're going to zero each other out. And what's left on the right? Just a 5. On the left, 6n minus 4n, that left them with 2n. Now you have to go after this minus 1 right here, because at this point we've just got a basic two-step equation, and when solving two-step equations, the final goal, the first thing you do is to undo addition and subtraction. We got a minus 1, we're going to make that minus 1 go away by adding 1 on both sides. These ones are going to zero each other out, leaving 2 times n, and on the right hand side, negative 5 plus 1. Signs are different. Find the difference with sign in front of a larger number go in front of your answer. That's going to give me a negative 4. And then we're going to take and undo multiplication and division by dividing 2 on both sides. The 2's on the left divide each other out, leaving n, and then negative 4 divided by 2. That's going to leave you with what? A negative 2. From there, check your answer, and the answer checks. That's all there is to solving these problems. Now you're going to get an opportunity to, we're going to skip that one over, don't care about algebra tiles, solve one of these on your own in working extra example 1. Once again, you don't have to keep that variable number positive in your first step, but I would encourage you to do that because you're less likely to make mistakes that way. So did you solve it? Let's take a look at what I'm going to do. My goal initially is to keep the x value positive because I'm less likely to make mistakes. So in doing that, I'm going to take this positive 3x and I'm going to subtract 3x on both sides. The 3x's on the left, boop, they are gone. And what does that leave? It leaves me with a negative 7 is equal to 8x minus 3x is going to give me a positive 5x plus 23. Next, I'm going to undo addition and subtraction by subtracting 23 from both sides on the right and on the left. In doing that, the 23's on the right zero each other out, leaving 5x is equal to, on the left-hand side, signs are the same. Find the sum. The sum of 7 and 23, that's going to equal to 30. The sign in front of your larger number, that's going to be negative. So from there, I'm going to divide both sides by 5. The 5's divide each other out, becoming 1. 1 times x is x, and negative 30 divided by 5 is going to give us a negative 6. But what if instead I worked it the other way? What if instead I ended up with a negative variable? How would that have affected my problem? Well, the answer is it really would not have changed it that much. So if I started off by subtracting 8x on both sides, those would zero out, and now I have negative 5x minus 7 is equal to 23. From here, I'm undoing addition and subtraction by adding 7 to both sides. those just zeroed out, leaving 5x is equal to what? I'm sorry, that should be a negative 5 right there. And then we're getting 5x is equal to what? A positive 30. And then we're going to undo multiplication by dividing a negative 5 on both sides. The negatives and the 5s divide out, leaving x is equal to a positive 30 divided by negative 5. You get the same exact answer. So either way you start it, with a positive variable or a negative variable, you're going to get the same answer to work with. Type in our answer here of negative 6. It checks. Easy math, folks. But we don't want to just deal with boring whole numbers here when we have glorious fractions to work with, and that's going to be our next problem in example 2. You have negative 2/3 x minus 1 is equal to 9 minus 1/6x. We're going to work it the same way we work the others, only now we're going to have to deal with some least common denominators. So my very first step is to isolate get the x's on one side or the other. And if it was me doing it, to keep my x's positive, I'd take that negative 1/6x, I'd move it to the left-hand side. Let's see what they chose to do. Wow, they just made a huge leap there. Oh no, I see what they did. Right here, they took the 2/3 x, they made it into 4/6x. That's a good move because they're going to be adding or subtracting this 1/3 x from it. So they had to have their least common denominators for their x terms. After that, what are we going to do? Well, we're going to take and do exactly what I said. Add 1/6x to both sides. They're working vertically. I don't like fractions vertical. The 1/6x's are going to, of course, zero each other out, leaving 9 on the right. And on the left-hand side, 4/6 plus 1/6, that's going to give them 5/6x. And then that minus 1, it's going to come down. From here, we're going to undo the addition and subtraction. You've got a minus 1, so we're going to take and add 1 to both sides, here and here. The 1's on the left are going to zero each other out, and what's that going to leave you with? 5/6x is equal to 9 plus 1 is 10. Now we have to undo multiplication and division. You got 5/6 times x, which means you got to divide both sides by 5/6 or multiply both sides by the reciprocal, which is what they did here. Now, they stuck it in the front. I keep telling you, don't put it in the front. It'll lead you to making mistakes later. Put the 6/5 after the 5/6 you're multiply. They did it correctly here. These, of course, are going to zero each other out, and then but not zero each other out, but divide each other out. And then on the right, you're going to have 10 over 1 times 6 over 5. The 5 and the 10 are going to simplify, becoming a 1 and a 2. That's going to give you 2 times 6 and 1 times 1, which is going to give you 12 over 1, also known as 12, for your final answer. Now, that's pretty in-depth instructions there. If you take a look, there's a fair bit of supporting work to go with that problem, but nothing overwhelming, nothing you don't know how to do. We're just putting things together you do know how to do into one happy package. This is where I'm going to end part 1, because when we come back, we're going to learn to do that same exact problem, but we're going to make those fractions go poof early on and totally get rid of them through something referred to as rationalizing the denominators. It's really cool, but it's also kind of tough, so make sure you watch that video.